we shall take up the problem. So here, see, work part will be given. You need to write the part program, okay, in order to execute milling operation in CNC machine. Okay, so here if you look at the sketch, total 3 operations are required. First one is pacing, second one is end milling, and the third one is drilling. Okay, following are the 3 operations required to perform or to obtain this final product. So you will be given some work part, okay, like of 100 mm width, okay, and 100 mm length and 80 mm width, and the thickness will be 17 mm. That will be the blank will be given to you, and based on the geometry of the required shape, we will write a part program, okay, using alpha numerical codes, okay, that is G code and M code. We will use the G code and M codes and certain CAN cycle, and we will write the program and execute the same program in CNC mill. Okay, so this is the software CNC mill, where you will have a space to enter the program. So this is a pre-written program. You can write in notepad and copy that and paste here, and you need to run this simulation, okay, in order to check your final work part. So I have entered the program. So your first step is to run the syntax. Okay, before that you select the machine data once. So machine data, that is Fanuc, select that and use syntax. So syntax is nothing but every operation will have a particular syntax, whether it is right or wrong. So it will check line by line, code by code. In case of any error, it will pop up. So as I said, for the given job, I need total 3 operations, starting facing. So I will select and assign a tool, that is face mill, and I will be selecting 40 mm dia. So please remember this, we are using a face mill, okay, of diameter 40 mm. So, and you can see the shape of that, okay. Done. Second is I need to use an end mill. So I will select an end mill of 20, okay. Okay, end mill is done, and the final I will assign drill bit, okay, that is twist drill, and the required hole diameter was 20. I will select the same 20 mm dia. So my 3 cutting tools are defined. So click OK, and this is your blank, okay. So the given blank will be of this, and we need to specify its length in X, Y, and Z direction. So in X, I will give it as 100. If you see the sketch, so 100 is the specified length, and the width 80. So take it 80. So thickness, I will take it as 17, and Z coordinate 0. 0 nothing but, so exactly how you are looking, the work part will position in that form, okay. So exactly the bottom point will be the origin position, that is 0, 0. If you give Z as 0, and here Y will be 0. So click OK, and you can change your view, that ISO plane, and if I run, so this is the operation that will perform. So I will get my true, okay, and it is not a through hole. Again, you can change the program so that you will obtain a through hole. So based on the given geometry, I have obtained my work part. See, to execute this, you need to write the program, okay. So you can use notepad to write the program. So this is the program which I have written and executed in CNC mill. So we will discuss this, how to write, okay. So total 3 operation is involved here, starting with facing. So please check. I will run the simulation again. So this is the first step, facing. You need to get the tool and see the cutting path. Okay. So the movement. So it is a 40 tool and it has a particular cutting path. So that will be defined with the help of coordinates. You will define the coordinate. Similarly, the second end mill, you need to define the cutting path. Okay. The particular tool will move to that particular position. Okay. And in cutting tool, there was a red mark. Okay, meaning initial movement there was a impact workpiece. Okay, we are not given any linear interpolation, even though there is an interaction. In practical situation, what will happen? There will be a damage to cutting tool as well as your work part. So you need to make sure that if you find such thing, you need to resolve that error. Okay, so we shall start writing the program, yeah, one by one. Okay, first I will we shall divide this complete process into three operations. As I said, facing, end milling, and finally you need to drill two holes, that is drilling. Okay. So we always start our program with, let me change, G80. Okay, G80. Let me erase. Okay, G80. So you should remember all G codes as well as M code. Okay, in order to write the part program. This is very important. So G80. So the meaning of G80 is to cancel the cant cycles. G40 in order to cancel the tool nose radius compensation, and G90. So this is we are using to indicate we are using absolute command, and followed with G28, nothing but automatic zero return. Okay. So next, what I will do, once it reaches the origin position, I will change the tool. Okay, M06 T01. M06, it is a M code, meaning you need to change the cutting tool of machine. So I have specified that as T01. If you remember, I sent the tool, the T01 as a face cutter of 40 dia. Okay, so we are using face mill of diameter 40 Okay, next, followed with, once you use M06, next, once you insert the tool, you should take care to compensate its length. Okay, as you seen in the simulation, different tool had different length. So all these tool will fix to the spindle. If I consider this as a spindle, what will happen? Tool will be fixed to the spindle. Okay. So above this portion, I will call it as a spindle, and the bottom portion, let me highlight it as a cutting tool. Okay. If I take an example of face cutter, and one more example, boring tool. Okay, so these two tool will have different length. So if I fix a spindle with face cutter, so let me consider it will have L1 as a length. If I fit a boring tool, again it may increase or decrease. It will be having a different length. So that offset you should mention in your program. Okay, so the length offset will be stored in the memory of the software. So, but you need to mention. So to do that, you need to write use G43. Nothing but I have used the face cutter, and the offset is in its H index, that is H1. Okay, done. So this is done. Then what I will do, and I will lift my tool, okay, from origin to the position of 35. Okay. Remember, if you want to move your spindle, like, see, for example, in this direction, above and below. So this will be the Z direction. So this direction will be the Y, and this direction will be the X. Okay. So if you remember, the thickness I assumed as the total thickness. Let me. So the total thickness I assume, given the total thickness, it is 17. And I have defined my Z coordinate as this point, that is 0, 0. So I need to make sure that this cutting tool, the first tool, has to locate above this work part. So that is Z35, meaning before come in contact with this work part, so my cutting tool will stay at Z35. So once it is done, switch on the spindle. For that, M03 S 1500. M03, so let me write in the M03 yes 1500. Okay, 1500. So this is spindle on in clockwise direction. Next, so I will select, okay, after Z35, just a minute, I need to add one more step that before switching on the spindle. So still my tool in origin position and lifted Z35, you need to get back to the coordinate. So for that you use G54 and move. See, for if I consider this complete area, okay, neglect the work part as a CNC work area. So there will be some work coordinate number 1, work coordinate number 2, work coordinate number 3. In each coordinate you may keep a specimen. Okay, so you need to select this particular coordinate. So I will always select as G54, so the first coordinate. Okay, so what I will do, from this origin I will move to the first coordinate in a quicker phase, that is G00. So when you want to move the cutting tool in a rapid way, then you use G00. Okay, that is the rapid movement, and I will position my cutting tool X0 and Y0. So this is my position of cutting tool. To that particular coordinate I have given 0, 0 as a position, X0, Y0. So exactly my cutting tool is at X. If I consider this as this complete area, let me erase, need not to confuse. So this complete area, this work part, okay, work part is kept in G54. So for this G54, this point will be the X0, Y0, and Z I have defined as 35. Exactly above 35 it will locate. So once it is done, now you switch on the spindle. M03 S1500, so that it will for the cutting operation. Okay, so then if you want to do a linear interpolation, okay, so that is you need to give G01, that is cutting action will takes place in straight line, that is the linear interpolation, G01. And So right now my cutting tool is at the height of Z35. So if I consider, see, now you can see the initial position. Initial position of my tool, which is coming from G28, the origin, it is above the work part. So this is, you can clearly, it is clearly visible. So from this point to here, it is having the height of 35. What it will do? So it will come to the 0 0 position, and 0 0 position above 35. It will locate here. So this distance will be 35. So next, in order to make cutting action, what you need to bring the cutting tool towards your work part. That is, you need to make sure that it has to remove 2 mm. The required thickness is, if you check in your sketch, so the required thickness is 10 plus 5, that is 15. 15 is the required thickness. So this blank is defined as 17 mm thickness. You need to remove 2 mm, so that you should get your cutting tool to the position of 15. So what I will do, G01 Z15 Z15, and I will define feed F200. Okay. Next, it's done. The cutting action will start. So if I show here, so it will start and it will move as per the cutting path. Okay. So now our role is to define the cutting path. So how to define the cutting path? So you need to define your work coordinate. So right now my cutting tool will make a position exactly here. That is x0, y0, z15. Now I should travel in this direction, as you've seen in the simulation, to this point, and lift. I will lift by 20 and again travel back to the initial position. So same operation you need to perform until you get the final work part. So if I show the same process with the help of paint, yeah. Okay. So initially you will locate here. This is the point, that is x0, y0, z15. Next, it will move to the x100. So this position will be x100, y0. And what I will do, I will give the y increment. So y increment as 20. Okay. So this cutting tool is exactly 40 mm of diameter. So I will lift 20. So it will come to this position. So the coordinate is x100, y20, and next to this position. So here x will be 0, y will be 20, and again I will lift. So that position is x0, y40, and towards right. So this position will be x100, y40, and again I will lift. See, if I lift, you can see the gap. So what I will do, I will lift 2 mm extra. I won't give y as 60 because I need to make sure that the complete area will be covered. Okay. Then I will come back to the last position here. and I will make sure that all material will be removed. So initially, so the position will be x0, x0, y0, and here x100, y0, and I will lift, x will be 100. Just a minute. Yeah. So x 100 and y will be 20. So x 100, y will be 20. I think the paint has some issue. So I hope you remember this coordinate. So this point, let me come back to, yeah, so I will write the same coordinate here. So the paint has some issue. Yeah. So initial position is already defined, x0, y0, z15. So from this position, I will move to x100, y will be 0. And again from that position, I will lift the cutting tool, x will be 100, y will be 20. And again from that position, I will get back to 0, y 0, and so x will be 0, y will be 20. And from here, I will lift again 20, that is y 40. And again from that to 100, I will move, y will remain 40. Okay, I will continue here, and x 100, I will move 62 that I have shown, because so that I will cover little behind the work part, so that complete area will be covered. So x0, y 62, and from here I will lift my cutting tool z100. So from that position I will lift the cutting tool and I will move back to G28, the origin position, and I will stop the spindle. To stop this spindle, M05. Okay, so this is from here to till here. So this is the indication, like a completion of facing. Okay, the next is end milling. You need to start with end milling. How to do the end milling? Same. See, now my spindle has stopped. So in order to do end milling, I need a new cutting tool. Okay, so let me erase few things here. Yeah. So remember, while starting with other second operation, the same process will be carried out. See, you can see here. Yeah, till here. Okay, the same process will be carried out. The same steps I will repeat. So if I want to insert the second tool, I will type M06, tool change, that is T02. So which tool I will use? I will use end mill of diameter, so 20, okay, 20 mm. Okay, done. Next, once you use the different cutting tool, you make sure that you offset the length, that is G43 H2. Okay, so you can lift your cutting tool. Okay. So make sure that your Z position you will define. So what I will do, I will lift my cutting tool as Z35, so above the tool. Okay, once it is done, next followed with coordinate. You need to select the coordinate. The same coordinate I will select, that is G54, G00. So rapid movement. Here in end milling, you need to make sure that you always keep your uh, cutting tool away from the work part. So if I show here, so please check the simulation while running. Okay. Okay. During the second tool, you can see it will start from away from the cutting tool. So it will start from this position. I hope you have seen. So it will stop. It will start from away from the work part. So for that, let me start with x5. I will give x5 and y as minus 15. Okay, so you execute as y as 25 because there was an red color damage. So y as minus 25, so that my cutting tool will start away from somewhere in this position. In this direction it will move. Okay, y as minus 25, and I will get this height to z10. Okay, so z10 is nothing but the required. If you check the sketch, so we need to remove the material. This is a sketch. See, this part has to be removed. Okay, if you check here, so that 10 mm, so this thickness will be 10. Okay, so I should get my cutting tool till this position, so that extra 5 mm will be removed. So here this portion will be removed. So same. So my positioning is done, and later I will start with M03. M03, that is the switch on the spindle. You can see here the same process, same steps that we are following. S 1500, M03 S 1500. Now I will start with my end linear interpolation G01. Now I will use a command G41. So this command is used in order to do the left compensation, that is tool nose radius left compensation. So you understand, if you see here, this cutting tool initial face cutter was moving with respect to center. Okay, so if I consider this as a work part, when you give a command of x0 y0, okay, so your cutting tool will come and locate exactly with respect to center. In the same way, I will use G41, and if I give X0, Y0 command, what happens? My cutting tool will come and locate in the left. This as a reference point. It will locate in that position. So that is G41. Okay. Why we are using G41? In case if you are changing the diameter, it will not affect the final geometry. So that is the reason we are using G41. So you can use 10 mm, 20 mm diameter. Okay, even if you change the final geometry will remain same. So G41, the syntax as follows: D02. Okay, that is representing the cutting tool number 2, and I will start with position X10, Y0, feed as 100. Okay, if you check the sketch, okay, let me move here. Yeah, see, initially I kept my cutting tool away somewhere here, and so this was my position. So this position was x5, y minus 25. So y will be negative in below and positive in the up direction. So I have kept away. So now I have given G41 and I have given this point. What will happen? The center location will change to the edge. It will position in this way. Now from here, I will move on to this position. Okay, this position will be y as 55. If you count 30, 45, 55. So this is the position. Next position is, this is the cutting path you need to follow. And here, here, here. So you need to remember its coordinate. So this position will be x as 25 and y as, you need to add 55 plus 15, that will be 70. And again, x will increase to this position 50, 60, 75 and y will remain 70. And here in this position, x will be 75 and y will be 55. Okay, so like that you define the complete path. And what will happen means, if you're using the lesser diameter, some amount of material will remain here at the end portion, and follow one more path to the exactly to the end portion, so that you will remove the particular material also. So if I show in the simulation, you can check, you can see the final, after running the end milling, the edges, so you can see here the edges will remain, and later you will run one more run, so that you will remove the particular material also. So let me start. So this is done. Now my role is to define the cutting path with the help of coordinates. Okay. So my initial position is done. Next, I will move to this point. This is the tip. So that will be, so let me write here, y55. y55. See this point. See, initially from here, from outside to here, x will be 10 itself and y will be 55. So next point will be here. Okay. Please check the, so next point I'm talking about here. Check the figure. You will be having the next position as x25, x25, y70. Okay, this position. Later here, x will be 75. So this position I'm talking about, y will be 70. So need not to change, need not to write y as 70 again. So you can make sure that once you write y70, unless and until you change, y will remain as a 70. You can write only once. So I have to change x distance from this point to here. I have to give x as 75. That is done. So x75 followed with x90. So this position, that is this position we are talking, x90, okay, y55. So next, y as 25, this point. And in this position, both x and y will change. That is x as 75, okay, y as 25. So let me write here. So I will start from, so the continuation I will do here. So x75, that is done. Next, x as 25. So this point. And next this, x as initial position, x as 10, y as 25. Next, what I will do, I will move to the last portion in order to remove the edges. y70, x90, y5, and x0. So lift your cutting tool to the 100. See, we have used G41, and you should make sure that you will cancel that. Okay, type G40. We have used left compensation, and make sure that you will cancel the same. G40 and return to initial position, that is G28. Switch off the spindle M05. So we have finished 2 operations. One is pacing, one more it is end milling. And we shall start. Let me erase all, I will delete all. So we shall start with the final, that is drilling. So drilling is very simple. You need to define 2 points. Okay. So you remember we have stopped the previous process with M05. We have stopped the spindle. Now once you stop the spindle, make sure that you will add cutting tool M06 T03 for drill bit. Okay. And when you add the cutting tool, you make sure that you will compensate G43 H3. So define it Z height, lift the cutting tool, Z100. I have lifted the cutting tool. Later, I will position in the work coordinate, the same coordinate G54. I will move the rapid movement. I will position exactly here. If you check the sketch, so that particular distance will be, so this is the point. So this will be X30 and Y as 40. So X30, Y 40. So that is the initial position. Later what I will do, I will switch on the spindle M03 as 1500, and now I want to do the drilling here. So for that I will use G99. We have two commands, G99 or G98. Okay, so G99 refers to the return to R position. So the same G98 refers to return to initial position. You can use both. Return to R position is nothing but to the safe height. After drilling this hole, you need to lift your drill bit, so that height it will define, that is R. Initial position is nothing but X30, Y40. So you should always give R as above 15 because the total thickness is 15. Okay, G99, and the drilling cycle is G81, the can cycle. And as I said, this is a syntax. You need to define the safe height, that is R as 17 and Z as, if you see it is not a through hole, I will define Z as minus 10 so that it will get a through hole. So it as minus 10 and define feed 200. Okay, once drilling is done, the cutting tool will lift it to the 17th position. Next, it has to move to drill the second hole. So the second hole, it has to move in X direction, that is 70. So from here to here it is 70, X70, and again it has to go Z minus 10. And after this, what I will do, I will lift. Okay, I will lift G100 and I will cancel G80. So I have used can cycle and I will cancel that and return to initial position, and I will stop the spindle, and here my program ends, M30. Okay, so this is how you write the part program. So if you want to write the part program, you should understand the concept of G codes, M codes. Okay, very simple, and the coordinates. So if you run through the coordinates, so you can write the part program. This is the manual execution. So you can type the same part program in the notepad. So you can see here the highlighted. So here I have typed. So copy that and paste here and execute. So let me do the changes. What I have said, I will delete. Okay. So the changes, what I mentioned is to get a through hole. Okay, I have given Z as minus 10 and one more again minus 10. Remember, you can in line you can add any number of codes. It doesn't mean that you should add only G28 or M05, nothing like that. You can add, so it will read one by one. Okay, it will take space as a discontinuation and it will move on to the next. Okay, no problem. So this is done, and again if I check my initial position of second tool, if I show again, please check here first portion. Here you can see the red mark. So that is the it is indicating something not happening as per the format. So what I will do, I will change that. So y minus 15, I will give little more away, like let me give 30 away from the. See, I have made a modification in my program, and you should make sure that you run the program again, then only it will consider. So this is, you need to run the program again. Yeah, now if I run, you can notice, you may not see it started from away from the work part, and I will get a through hole. Okay, let me see. You can see the second tool, which will be starting its cutting operation away from the, yeah, you can see the distance. I have given 30. Okay, because the end mill cutter has to start from away from the work part due to its geometry. So you can see the leftovers. Again, it will be removed in another pass. And finally, you will get a two drill holes of 20 mm. See the written position, that is what I meant. That is a safe height. Okay. Let me stop here.